Hey guys, these notes are coming to you a little bit differently because I have written them all out already and just want to kind of show you some key pieces. And so we are looking at the notes that I wrote that you can see on Classroom, and I'm just going to kind of walk you through the key pieces. There is a delta math that goes with this, and in doing that delta math, there are 2 questions at the end that I also will record a video that goes with them so that you can see kind of how this all fits together, right? And so hopefully you get the chance to watch that as well, especially before you do the delta math, or maybe as you're doing the delta math, to kind of help you with some of what's going on with that, because there's a lot of pieces to these rational graphs. So as we're looking at this, first of all, a key vocab word is asymptote, which is a line the graph will approach but not cross. Okay, so we're going to get closer and closer and closer, but we're never actually going to cross over that line, especially as we go further out to the infinities. We have 2 types. We have horizontal asymptotes and vertical, right? We're familiar with horizontal lines, vertical lines. We're just going to apply them to these graphs. So for horizontal lines, we see equations that say y equals a number. And then for vertical lines, we see the same thing, except for now it says x equals a number. So to see all this in action, I'm going to look at this graph down here. And the first thing I'm going to point you out is the horizontal asymptote. That is this horizontal line right there. HA I'm using to stand for horizontal asymptote. And it's y equals 2 because I cross the y-axis at 2. So that's how I got that line. The vertical asymptote, the VA, is this line right here. And it's x equals 1. Okay, so those are the 2 asymptotes of this graph. Now, as we're looking at this graph, there's some other key pieces that we're going to talk about. The first is the y-intercept. Okay, the y-intercept is a point on the y-axis where our graph crosses. In this case, it does it at 0, 4. And the x-intercept, same thing on the x-axis, it's 0, 3. So when you're about to hear me talk about how to find all of these things, and when you watch the video that goes with the delta math, you will hopefully kind of be able to visualize them now that we've talked through this graph. So on the right-hand side of these notes, I've got all 5 parts, and I'm going to walk you through each part. The first one is horizontal asymptotes. We're kicking off with the ha, right? And the ha comes from comparing the degree of the numerator and the denominator. And when I say degree, remember, degree is the biggest exponent that we're looking at. And so we're comparing the exponents of the numerator to the exponents of the denominator. If we're bigger on top, there's no horizontal asymptote. If we're bigger on the bottom, we write y equals 0. And if we're exactly the same, we make a fraction out of their leading coefficient, which is just the first number in each one. So that's how I do horizontal asymptote. Vertical asymptote is much, much easier. We're just looking at what numbers make the denominator 0. And remember, x, let's try that again and make it look like an actual x. When we are doing vertical asymptotes, we are saying that x lies, which is very convenient because it also happens to lie for the x-intercept. And the x-intercept comes from doing the same process as vertical asymptotes, but in the numerator. And we write those as an ordered pair with the x number that we get and a 0. Okay. So far we've dealt with the degrees, we've dealt with the denominator, we've dealt with the numerator. We're doing okay. The y-intercept and wholes require us to do some substituting. So the y-intercept says plug in 0 for x anywhere in the equation where we see x, we are going to put in 0. And then we will get an ordered pair with some number 0y. For wholes, this is the tricky one. A hole in a graph means the graph doesn't exist at a specific point. So if I was going to put in a hole on this graph, maybe I'll put it way over here, I would draw like a little circle to show that there's a hole. Desmos does not nicely show holes, so be careful when you're using Desmos. But what happens with what happens with holes is we're looking for in a graph or in the equation, if there's anything that cancels. So say I have x plus 5 over x plus 5, and that would cancel out like we've been doing in this unit. That means that we would have a hole where x equals -5. Remember, x lies. And then we'll plug in -5 and find the y coordinate. So when you do have a hole, it is slightly more tricky because it's got 2 steps to it, right? First, we got to find out what x is. Then we got to find out what y is. So as you're working through that, just be mindful of holes are a little bit trickier. Now, that was a lot of notes and not a lot of time. And part of the reason is I want you to spend more time looking at the videos that go with the Delta Math assignment. So just be mindful of that and watch through those and use those to help you.